Hello everyone, my name is Bhawani Singh and I have done my masters in physics. Okay, masters in physics from IIT Guwahati and I graduated this year. So I'm just trying to help the students and so that I'm going to put videos based on the problems on different topics of JEE and NEET. So in today's lecture I will solve problems related to the projectile motion that will be of level of NEET and JEE. Okay. So from now onwards, I'll be going to put videos related to the all the topics that I'll be able to do. So you can see my YouTube channel for this kind of content for all the problems related to JEE and NEET, and you can prepare yourself for the upcoming exams. So today we are going to solve problems based on the projectile motion. So our very first problem is we have to find out in a projectile motion the velocity is whether always perpendicular to the acceleration or it is never perpendicular to the acceleration or perpendicular to the acceleration for one instant only or perpendicular to the acceleration for two instants. So first of all, we know in a projectile motion, whenever talk we talk about the velocity in x direction and velocity in the y direction. So initially when our particle is at this point, its velocity is in both direction, that is x component of velocity if it is making some angle theta or velocity, and y component of velocity, that is uy, right? But here we can say and the acceleration will be always downward. So acceleration will be always downward, right? And initially your velocity is not perpendicular to the acceleration. You can see here it is making some angle with g, right? The initially the angle your velocity that will make, that will be 90 plus theta, right? But when you talk about the highest point, when your particle reach at highest point in y direction, which means h max, at h max we know our vertical velocity at this point vy becomes 0 and the velocity only remains in the x direction. So velocity component in x direction will only remain there. Velocity component in y direction will be 0. So now at highest maximum point, at h max point, we can see velocity will be equal to only vx, and at this point gravitational acceleration will also be in the downward direction, and acceleration in x direction is always 0, right? So ax is 0 and ay is minus g, right? So here we can see that gravitational acceleration is making 90-degree angle with g, sorry, vx. Okay, and anywhere else you will see here when it particle comes downward, it will have the x component as well as the y component, but this time while returning, the y component will be in the downward direction, and while going up, the y direction is always in upward direction. So we can conclude here that our velocity vector is perpendicular to acceleration at h max point only. So which option is correct? Option 3, perpendicular to the acceleration for one instant only. Okay. Let me move on to the next question. The next question is You have a bomb is fired from a cannon with a velocity of 1000 meter per second, making an angle of 30 degree with the horizontal. We have to find out what is the time taken by the bomb to reach the highest point. So, situation is like this. The bomb is thrown with the velocity. Let's suppose this is a trajectory of your bomb, and this is initial velocity, that is 1000 meter per second, and the angle it is making, that is 30 degree, right? So we are asked, when our bomb will reach the highest point, what will be the time, right? So we can say that from this point to this point P, the time it will take, that will be the time of ascending, right? Time to reach the maximum point in y direction, which means h max, that will be equal to the ascending time. And we know the formula for ascending time, that is u sine theta by g. And the other way we can do is, at highest maximum point, our velocity in y direction will be 0. So we can apply the equation of motion, Vy equal to Qy plus Ayt, right? So Vy is 0, Uy will be what? Uy will be this, U sine 30 degree, right? So Uy will be U sine 30 degree, and Ay is minus G, right? Ay will be minus G. So your T will be U sine theta by G. Similar to your, this is how we get our formula for ascending time. And I directly use the ascending time formula here. So you put the value of U, theta and all, G also, and you will find U is your 1000 meter per second, right? Sine 30 is 1 by 2, and G, let me take it 10, right? So it will be 500 divided by 10. So it will be T equal to 50 seconds. So your bomb will take 50 seconds to reach the maximum point. Okay, let me move to the next question. The question number third is, you have a body that is thrown with a velocity of 19.6 meter per second, making an angle of 30 degree with the horizontal. It will hit the ground after time. So you are throwing a body with some velocity of 19.6 meter per second and angle of 30 degree, right? So when it will reach, hit the ground, so when it reached, let's suppose this is O and this is P. So when your particle or your body reaches to the ground, right, the total time it will take, that will be the what? Total time of flight to reach O to P, right? The total time will be what? Total time of flight, right? Capital T. And we know total time of flight is nothing but 2u sine theta by g, and that is also equal to the time of ascending plus time of descending. And in case of projectile motion, when acceleration is uniform, t ascending is equal to our t descending. Okay, so you just put the values of u, g and theta here, and you will find the solution. So u is given to you 19.6 sine 30, and g you can use 9.8. So you see sine 30 will be 1 by 2. So 1, 2 cancel out with this 2, and this will also will cancel out with 2 times. So time to reach from point O to point P, which means to hit the ground will the particle will take only 2 seconds. That is equal to the total time of flight also. Okay, let me move to the next problem. Problem number 4 is, if a projectile is fired at an angle theta to the vertical with the velocity u, then the maximum height attained is given by. So you see the question carefully. Your particle is having the initial velocity u, right? And it is making angle theta not with horizontal, okay? It is making theta angle with vertical, which means with y-axis, okay? Right. So your angle made with horizontal will be 90 minus theta instead of only theta. Okay. So the conventional formula that we already know for the maximum height, right? H max. That is what? That is u square sine square theta by 2g. Right. But this is not correct in this situation because your angle is no longer theta made with the horizontal axis, right? It is 90 minus theta. So you replace your theta with 90 minus theta in particular equation 1. Okay. Then what will be your H max formula become? U square will remain same. 2g will also remain same. In sine theta, you place 90 minus theta and its square is already there. So we know sine 90 minus theta is what? Is equal to cos theta, and that is positive in first quadrant, right? So what will become your H max formula now? It will become u square cos square theta by 2g. I hope you guys understanding all the question. Okay, let me move ahead to the problem number 4. Sorry, 5. So yeah, now you see, in case of a projectile fired at an angle 60 degree to the horizontal with the velocity u, the horizontal range is, okay, I don't think it's a very difficult problem. It's a very easy problem. So you don't have to waste so much time on these kind of questions. You just so your let's suppose your initial velocity is u and the angle made with the horizontal axis is given the 60 degree, right? And you have to find the horizontal range, right? Range formula we know u square sine 2 theta by g, right? So you put the value. You can see the options. Answer is given in terms of u and g, right? So you keep u square g and sine 2 theta. So you put the value 2. So 2 theta will be equal to what? 120 degree because theta is 60, right? And 2 theta will be 120 degree. So sine 120 is what? Sine 120. Sine 20, you can write it like this, sine 180 minus 60, right? So it will be equal to sine 60 and that is equal to root 3 by 2. It is in second quadrant, right? And in second quadrant sign is positive, so your answer will also be positive. So you put root 3 by 2 u square by g. That is the answer for your question. Which option? Option 2. Now let me move to the next problem. Problem number 6. Okay. Yeah. Problem number 6. The range of a projectile when fired at 60 degree to the horizontal is 0.5 kilometer. What will be the range if it is fired at 45 degree but the angle speed remains the same? So let's suppose when it is fired with, I know, let's suppose it is 45 degree and this is 60-degree angle, right? The velocity it is making, that is same, right? So let's suppose in this situation your range is R1 and this situation your range is R2. You know the formula for range, that is u square sine 2 theta by g, right? So if we take the ratio of, because your u is in both the situation u is same, right? And g is already constant, right? So u square by g will remains constant, right? So your r will be proportional to what? Sine 2 theta, right? So so range is directly proportional to the angle. So let me take the ratio of R1 and R2, right? So it will be what? For R1, our angle is sine 60 degree, right? So 2 theta will make it 120 degree, and for R2, the angle is 50 degree, right? So for 2 theta will make it 90 degree, right? So so the ratio will become sine 120 will become root 3 by 2 and sine 90 will become 1, right? So what we have to find out, in the horizontal range in case of 60 degree, right? That is given to 0.5 kilometer, right? So now if we have to find out R2, right? So what will be R2? That will be 2R1 by root 3, right? 2 by root 3 multiplied with range R1, right? Range R1 is 0.5 kilometer. So your range R2 will be 1 kilometer, sorry, 1 by root 3 kilometer. Okay, so you see your option 2 is correct. Now let me take the next question, question number 7, right? So the question is saying a cricketer can throw a ball to the maximum horizontal distance of 100 meter. Okay, so he's asking how much high above the ground can the cricketer uh, throw the same ball. Okay, so you are given the maximum horizontal range in this situation, right? You are given maximum horizontal range. So you are given maximum horizontal range, that is given to you 100 meter, right? And you have to find out what is how much high above the ground can the cricketer throw the same ball. So we have to find out that maximum height that this ball will achieve. Okay, right? So we can use here R max formula, right? In which situation are this range become the maximum, right? That we know, right? If we throw our particle at 45-degree angle, right? If we throw our projectile at 45-degree, then your achieved range is R max, right? And what is the formula for R max? R, for R we know u square sine 2 theta by g, and if you put the 45-degree here, the R max formula will be what? U square by g, because sine 2 theta, which means sine 90 will be 1. So R max is u square by g. Okay. Similarly, we have to find out h max, right? H max, what will be the formula for h max? For h, we know it is u square sine square theta by 2g, right? For h maximum is at theta equal to 90 degree, right? So h max is u square by 2g. Now from the range formula, we already know u square by g, right? That is given to you. R maximum is given to us already. That is 100 meter here, right? So what value we have? We have value u square by g here. So our h max become 1 by 2 of u square by g, right? And you, in place of u square by g, we can put the value 100, right? So our h max will become 50 meter, right? So which option is correct? Option 4. Let me take the next question. Question number 8. So question number 8 is saying a ball whose kinetic energy E is thrown. A ball whose kinetic energy E is thrown at an angle of 60 degree to the horizontal. We have to see what will be its kinetic energy at the highest point of its flight, right? So let's suppose it is thrown with initial velocity u, right? And it will reach the highest maximum point here, right? And we know at h max, at h max point, velocity in the y direction is 0. Velocity is only in the x direction, that is ux, right? And velocity in the x direction in case of projectile, that remains constant everywhere, right? That will be vx, right? So velocity vx will be equal to ux, and that we know that is u cos theta, right? So if we have initial velocity u, right? So what is our initial kinetic energy? Let's suppose that is E, right? So kinetic energy formula that we know, that is 1 by 2 mv square, right? If we have initial velocity u, so in place of v, we will use u. So our initial kinetic energy is 1 by 2 mu square. So when particle is at h max, right? So your vy is 0. So your final velocity at h max will be equal to only u vx, right? And that is equal to u cos theta. And you see your particle is thrown at an angle of 60 degree, right? So which means theta is 60 degree. You see in the question, it is thrown at 60 degree angle, right? So your, in this situation, your v will become what? U cos theta and cos 60. Cos 60 is what? Nothing, u by cos 60 is 1 by 2. So your v will become 1 by, sorry, u by 2. So your kinetic energy at h max, right? What it will become? It will be, let's suppose it is E1, okay? Right? So E1 will be 1 by 2 mv square, and we put the value of v, that is u by 2 square, and you see you will have 1 by 2 m u square by 4. And you can see this is what? This is your initial kinetic energy E, right? So your E1 will be what? E by 4. So your kinetic energy at maximum point will be 1/4 of your initial kinetic energy. And which option is correct? Option A. So let me take now the next question. This is question number 9. The question number 9 is saying two stones are projected horizontally from the same height with a speed of 100 meter per second and 40 meter per second. The ratio of their horizontal range, right? So let me draw the diagram firstly. Let's suppose this is some height, and from this height, your first stone is thrown with a speed of 100 meter per second, right? So let's suppose its range will be something here, that will be r1, right? Now from the same height the second particle is thrown at 40 meter per second, right? So the range of this particle should be lesser, its velocity is also lower, right? So let's suppose this range is R2. So what we are asked, we have to find out the ratio of their horizontal ranges. Okay, so we have to find R1 by R2. This is what we have to find out. And we have U1 is 100 meter per second and U2 is 40 meter per second, right? So we are asked horizontal range. So you can see both the particles are falling from the same height h, right? So the total time of flight will be same, the time that they will take to reach the ground, right? So the horizontal range formula, we can use the equation of motion, second equation of motion, that is x equal to ut plus half at square, right? If we are using the x means horizontal direction, so we'll use the x component of velocity and acceleration, and we know that there is no acceleration in x direction in case of projectile motion. So ax is 0, so this term will become 0. Now, and x, let's suppose it's range, right? So your formula for range will become ut, right? And ux is your the velocity that is given to u, initial velocity, that is horizontal velocity, right? So we directly use the formula, we put the value of r1 and r2, right? So r1 by r2 will be u1t by u2t. Time will be similar in both the case as they are falling from the same height, right? So time will be same. So we'll cancel out time with time and you will have u1 by u2. So u1 value is 100 meter per second and u2 value is 40 meter per second, right? So you can see here the r1 by r2 ratio is nothing but 10 by 4, it will be 5 by 2. So the ratio will become 5 by 2, right? So that is our answer. Okay. So now let me see our question number 10. So question number 10 is saying we have an aeroplane that is moving horizontally with a speed of 90 km per hour, right? So let's suppose this aeroplane is aeroplane's velocity is in this direction, that is 90 km per hour, right? And height of this aeroplane is given from the earth is 490 meter, right? So due to the gravity, it's the object that will fall from the that food packet, right? That food packet will follow this kind of path. Hmm, okay. So we are asked the horizontal range of this packet. Okay, we are asked the horizontal range of this packet. Let's suppose the range the food packet will cover, that is R, right? So the range formula in the upper case we have seen, because it's horizontal, so the formula will be similar to this, right? Rx equal R will be equal to ut, right? Because the acceleration in the x direction is 0. So your formula for range will be what? R equal to uxt plus half xt square. This term will be 0 as ax is 0, right? So our horizontal range will be r equal to uxt, right? So you see you are given the initial speed, right? That is in horizontal direction, which means that velocity is ux and that is 90 km per hour. You can convert into the meter per second, that we have to multiply it by 5 by 18, right? So it will be 25 meter per second. 18 will divide 90 by 5 times and 5 with multiply with 5 will give you 25 meter per second. So this is the speed of your aeroplane. Now, so we have this velocity, but we need this time, total time. Okay, it will take during its time of like flight, during the flight. So we know what other information that is given in the question, that is given this height, right? Which means we know the vertical displacement in the x direction. When your particle reach this time, the vertical displacement it will cover, that will be equal to 490. So we can use the equation of motion, second equation of motion in y direction, and we'll use y equal to uyt plus half ayt square, right? So gravitational acceleration will always be in this downward direction, right? Anyway, and uy is what? There is no initial velocity in the y direction. The velocity was only in the x direction, that is mentioned in the question itself. Aeroplane moving horizontally with the speed of 90 km per hour. So no initial velocity in the vertical direction. So uy is 0. And ay will be what? Ay will be, if we take, ay will be minus g, right? So y y will be what? Y, let's suppose it's horizontal, sorry, vertical displacement. So it is 490 meter. So we'll put all the values 490 in equation 2, right? So 490 will be equal to 0 minus gt square, right? If we take the only the magnitude part, right? Only the magnitude, right? Magnitude of the displacement, so it will be 490 1 by 2 gt square. Or other thing you can do, you can take this downward direction as positive also, because the direction you can choose by yourself. So here, if you solve, if you put the g value equal to 10, right? If you put the g value 10, 490 equal to 1 by 2, g value is 10 t square, right? So you see it will be 49, right? And 49 multiplied with 2 equal to t square. T will be square root of 98. This value come around 9.9 second, right? If you take g value 9.8 here, right? Then this will be exact 10 second, okay? And from the equation 1, you have to find what we are asked in the question, horizontal range, right? The horizontal range is uxt. So we have the u value, so we can write from equation 1, right? So r will be, horizontal velocity is how much? 25 meter per second, and the time that it will take to reach the ground, and that will be 9.9 second, right? So it will be almost 250 meter, right? You see option B, that is exact 250 meter is given to. If you take G value 9.8, you will get exact 250 meter, right? So I hope this question is clear. Let me move to the next question. The next question is, when a particle is thrown horizontally, the displacement of the particle at any time t is given by, right? So we are asked the displacement of your particle after some time. So let's suppose it should be a particle is thrown horizontally from some height, right? So let's suppose there is some particle that is thrown from a height, and it is thrown horizontal, right? So due to gravity, its path will be like this. So let's suppose after t time, its particle is here. So we need the coordinate for this particular time, right? Let's suppose here the time it is taking, that is t, right? So you can write x, y, and t, right? So we need coordinate this x and y, right? So from the very last question, we know already that how did we find Rx? Rx we find using the displacement formula in the horizontal direction, and Y, right? That is your vertical displacement that we find by using the equation of motion in the y direction. So first of all, the similarly that x, right? So second equation of motion that we know, this is s equal to ut plus half at t square, right? So first use in x direction, right? So x direction, it will be what? In x, s will become x, that will be the x distance, right? And u will become ux, and that is t. There is no acceleration in the x direction, right? So it will be axt square. So this term will become 0. And you know, horizontal velocity, let's suppose initial velocity is u horizontally, right? So ux will be u. So x will become ut, right? Now let me apply the same equation of motion in the y direction. So in the y direction, this time your displacement will become y, initial velocity will become y, t 1 by 2 a y dt square, right? So you see uy in initial initial time, right? Uy is 0 because there is no initial velocity in the vertical direction, right? So your y will become, and this ay is what? Minus g, that is in downward direction here, right? So your y will be minus 1 by 2 gt square. So you have now y and x coordinate, right? So the total displacement, right? Total displacement. Total displacement will be what? Square root of x square plus y square, right? We are just taking the magnitude of displacement. Otherwise, you can also write the displacement like this, as equal to xi plus yj, right? As equal to ut ikf minus gt square jk, right? When we take the magnitude of this, right? It will be under root x square plus y square, and that is equal to x is ut, so x square will be u square t square and square of minus gt square. So overall your displacement will become u square t square plus 1 by 4 g square t to the power 4. I hope this is clear. Let me match the option. You see the option 2? That is correct, right? Let me take our next problem. Question number 12. Right. So question number 12 is saying a particle is projected horizontally with a speed of 20 root 3 meter per second from height at t equal to 0. At what time will its velocity make 30-degree angle with the initial velocity? Okay. So let's suppose we have some height, right? This height, and at t equal to 0, right? Your particle is projected horizontally with some speed that is 2 root 3 meter per second, right? So due to gravity, its path will be like this. So, so after some time, you are asked that your velocity, right? Let's suppose our velocity at this particular point is in this direction, okay? So its horizontal component will be in this direction and its vertical component will be in this direction. So this is, let's suppose, Vx after some time, and this is Vy, right? And this was your U, Ux, right? Because particle is thrown horizontally. So we have this is your total velocity. So we are asked after This angle is making 30 degree. It's on 30 degree, right? Your question asking that at what time will its velocity make 30-degree angle with the initial velocity. So initial velocity was what? That was velocity in the x direction, right? So initial velocity was ux, that was 2 root 3 meter per second, and we know that in projectile velocity in the horizontal direction will remain same. So u vx will be equal to ux, right? That is 2 root 3 meter per second, right? So that vx equal to ux. So at what time your this velocity will make this 30-degree angle with your velocity in the horizontal direction, okay, which is your initial velocity. Got it? So we have to find this time, right? So what we can do here? So first of all, what the this was 20 by root 3, not 20 root 3, okay? This was 20 by root 3 in the question, you see. Okay, so we have to find this time. So what we can do, so initially at t equal to 0, right? At t equal to 0, your ux is what? 20 by root 3 meter per second, right? And uy is what? 0, because no vertical velocity. So after t time, right? After t second or t time, what its velocity? Vx will be equal to ux, that is already understood, I hope. And vy, this will be changed, right? So Vy formula we know V equal to U plus AT. So Vy will be equal to Uy plus Ayt. So Uy is 0. So it will be 0. So Vy will be what? Vy will be your Gt. Right? So you see, we are asked, we have to find the time, right? So what we can do, we can take this downward direction positive, right? This will not change anything. So Vy and Gt, right? If I put what we can do here, we have to find the time. We have to find this time t. So what do we need? We need this Vy because we G already know, right? Vx we have, but we have to find out the Vy so that we can get the time, right? So how can we get this Vy? So you see, your velocity after t time is making some angle 30-degree with your initial velocity, right? So can you tell me if this is your Vx, right? So this length will be equal to what? Vx. This length is equal to Vy, right? So if I draw a perpendicular here, right, and velocity if I match, this will also be equal to Vy or not? I hope you can assume it. So in this triangle, in this particular triangle, right? So you tell me what is this tan 30 will be. Let's suppose we can give it triangle OPQ, right? Triangle OPQ. So here tan 30 is equal to tan theta equal to perpendicular by base, right? So perpendicular will be equal to Vy and base will be what? Vx. Okay, PQ OP, right? So tan 30 is how much? Tan 30 we know it is 1 by root 3, right? And Vy we have to find out, and Vx we know that is 20 by root 3. So your Vy will become here 20 by root 3 multiplied with 1 by root 3. So your Vy has become 20 by 3 meter per second. So here now you see equation 1. We have Vy, we know the G, so we can get the T. So just put the value of Vy here. That now it will become 20 by 3. G value, let me take the 10. And T that we have to find out. So 10 will cancel out 20 with 2 times. And your time will be 2 by 3 second. So after 2 by 3 second, your particle will make 30-degree angle with initial velocity, that is your horizontal velocity ux. I hope this question is clear to all of you. Let me move to the next question. That is question number 3. Right. So you see, we are given a lift is moving upward, right? So we have a lift. Lift is moving upward with acceleration A, right? A man in the lift, right? A man that is inside the lift drops a ball within the lift. Man drops a ball within the lift. The acceleration of the ball observed by the man in the lift. Okay, we have to find the acceleration of the ball observed by this man, right? And we also have to find out the acceleration of the ball. A man is with respect to a man standing stationary on the ground or respect. Let's suppose a person is standing somewhere here, right? So with respect to this person, what will be the acceleration of this ball, right? This ball. So how can we find it out? So acceleration of the ball inside the lift observed by the man will be what? Right, first of you tell me. So acceleration of ball with respect to the lift, right? Because the man is also moving with respect to the lift. So the acceleration of the ball observed by the man will be equal to the acceleration of all ball with respect to the lift. So using the relativity concept, right? So your acceleration of ball, right, will be acceleration of ball minus acceleration of the lift. So you see, your ball is coming downward when it is released by this person. So its acceleration is g or not. And if you take the this direction negative and this direction positive, right? So your this g will be negative, right? So acceleration of ball will be minus g, and your lift is going upward, right? So acceleration of your lift, right? That is your a. Your a ball will be what? Minus acceleration of ball with respect to the lift, which means acceleration of your ball with respect to the man inside the lift. So that will be g plus a, which means this negative sign showing here that your ball is going downward not only with the g but it with g plus a. Your this man to this man, your ball looks like it is going downward with the acceleration not g but with the acceleration g plus a. This minus sign is showing that your ball is going downward. Okay, so the first thing is clear. Now let me find out the second thing. Acceleration of the ball with respect to a man is standing stationary on the ground are respectively, right? So according to you, what should be with respect to this man? You see, when this person release the ball, right, this man observe only that this ball is coming downward with the gravitational acceleration only. Okay, with respect to this man, there is no effect of the lift acceleration on this ball according to this person. Okay, so your acceleration of your ball with respect to the person that is at ground, right, will be nothing but acceleration of the acceleration due to gravity, and this man will look. So this man will see that ball is falling downward with the gravitational acceleration. Okay, I hope it is clear. So acceleration of the ball with respect to the person that is outside stationary at ground, that will be the minus g, which means it is ball is looking like it's coming downward with the acceleration g. And here the person it is that is inside the lift, he seems that the ball is going downward with acceleration not g but the g plus a. I hope this question is clear. Let me move to the next question. Question number 14. So question number 14 is saying a projectile is thrown into a space so as to have the maximum possible range, horizontal range, that is equal to 200 kilometer, right? Taking the point of projection as the origin, right? We have to find the coordinate of the point where the velocity of the projectile is minimum. Where will be the minimum coordinate of the velocity is minimum, right? So we have to find out the coordinates where your velocity is minimum. So first of all, we are given maximum possible horizontal range, right? You see, maximum possible horizontal range, that is equal to 200 meter. So we are given R max, right? That is 200 meter, and we know the maximum range is possible at theta equal to 45 degree, right? So let's suppose this is your particle, this is your range, that is 200 meter, right? Now we know that highest maximum point, right? Your vertical velocity is always zero at this point. Vy is zero because only the horizontal velocity is present there, right? Now we can see, so your at h max, right? At h max, your Vy is zero, right? So only Vx is present there, right? So velocity will be minimum at what point? Anywhere else you see, here, 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 everywhere, Vx and Vy, both the components will be present. So your minimum velocity is possible at the h max point only. So minimum velocity is possible at at h max only. At h max only, right? So the coordinate of this point, we know coordinate, if I want to find out the coordinate, that will be equal to what? The horizontal coordinate, that is total range. So x direction coordinate up to this point will be r by 2 or not. So x coordinate will be r by 2, and the horizontal vertical distance, right, that is will be equal to h max, right? So the coordinates will be what? That will be r by 2 and h max. And we know for theta equal to 45 degree, right? For theta equal to 45 degree, h max formula is what? H max formula is what? That is u square by sine 2 theta by u square sine square theta by 2g, right? So when we put the value, we'll get h max equal to theta equal to 45 degree. We will get u square sine square theta by 2g. So you put theta equal to 45 degree, and sine 45 degree is what? 1 by root 2. So 1 by root 2 square will be 1 by 2, and 1 by 2 and 1 by 2 will become u square by 4g, and u square by g is what? Your r max, right? Maximum r, so it will become r by 4. So your coordinates now has become, because this u square by g is nothing but your r, right, at 45 degree. So your coordinates will become r by 2 and r by 4, and r is given to you, that is how much? That is given to 200. So your coordinates will be 200 by 2 and 200 by 4, right? So it will become 150. So 150 will be the coordinate for this particular point. So which option is correct? Option 3. I hope this question is clear. Let me see the very next question. That is question number 15. So the 15 number question is saying a body is thrown horizontally with a velocity of 20 meter per second, right? From the top of a tower of 20 meter height. So height of your tower is given 20 meter. right? The velocity horizontally, right? That is also given 20 meter per second. It strikes the level ground through at the foot of the tower. At a distance of x from the tower, right? So this distance is given is x. So we have to find the value of x here, right? So what is information given? First of all, that ux is given to you. Sorry. So ux is given to 20 meter per second, right? And h is given 20 meter. So first of all, let me apply what will be the displacement in the y direction when your particle reach here, right? So displacement in the vertical direction will be only 20 meter, that is given to us, right? So can we apply that? And what is uy? It is 0 because no vertical velocity is given. So if we, when your particle is here, right, it reaches the ground, can we apply the y displacement formula, and then we know that sy will be equal to uyt plus half ayt square, right? Uy is 0, so this term will become 0, and ay will be what? Ay is nothing but what? G, right? So sy will be 1 by 2 gt square. So you can take the downward direction as positive, so your ay will be the g, right? So s value is how much given? Sy will be equal to what? This 20 meter height, because this is a displacement in the y direction. So it will be 20 meter, 1 by 2, and g value, let me take the 10, and t square. So we can find the total time it will take to reach the ground. So it will be 40. So it will become 4, and t will be what? Square root of 4, that is t equal to 2 seconds. So we have the total time that it will take to reach the ground, right? So can we find this range that will be equal to this x or not, right? So if we find the range, that formula for the range using the equation of motion, the second equation of motion in the x direction, that will be uxt plus half axt square, and we know the acceleration in the x direction nothing but 0, so this term becomes 0. So your range will become uxt. This range will be equal to this x or not? Of course it is. So x will be equal to ux. Ux is given to you 20 meter per second, and the time that you have already figured it out, that is 2 seconds. So it will multiply this 20. And the range it will give, that will be equal to 40 meter. So your body will cover this distance, right? The distance of the distance x from this tower, right? That will be how much? 40 meter. So option 3 is correct. I hope you guys are enjoying the lecture. So let me move to the next problem. So we have solved the 15 questions so far. We'll solve around 20 to 25 questions. Okay. So question number 16 is saying that a boy wants to jump, right, from building A to building B, and height of the building A is given to you 39.2 meter, and building B is 19.6 meter, right? So first of all, so this height, total height is given to you, that is how much? 39.2 meter, right? This height. And let's suppose this building is A. And the second building height, that is also given to you, that is equal to 19.6 meter, right? So let's suppose this is B, and the distance between buildings is also given this distance, right? That is 20 meter. So the question is saying, assuming boy jumps horizontally, boy is from here, right? This is the build. From here a boy wants to jump. I don't know why he's jumping. Although height is also too much, no? So he wants to jump from this building A to this building B, right? A boy jump from building A to building B, right? So we have to calculate the minimum velocity with which boy has to jump to land safely on building. Okay, boy is landing safely. We have to find that velocity. So with which horizontal velocity that boy should jump that it will reach here safely. Okay. So what is that horizontal velocity? So we know if it is 20 meter, this will also be 20 meter, right? And if this value is 19.6 meters, so this will also be the 19.6 or not, right? So if this total is 39.2, right? You see, and this up to this, right? This is given to you, that is 19.6. So this value will also be equal to what? This will also be equal to 9.6, 19.6 meter. Right. So now we have the height. Okay. So which means we have height means we have the y direction displacement. Okay, vertical displacement of the boy when it reaches to the building B top, right here. So we have this value. So we use the equation of motion, second equation of motion in the y direction. So equation of motion, second equation of motion is s equal to ut plus half at square, right? In the y direction, it will be sy equal to uyt plus half ayt square, right? So let me take y. Uy is what? Uy is 0 because no initial velocity is only in which direction? Ux direction. So uy is 0 and we have to find it, right? So y equal to 0. So it will be 0 equal to, sorry, not y equal to 0. Uy equal to 0, right? So this term will become 0 plus ay will be what? It will be g and t square. We are taking the downward direction as positive, right? So y will be what? Y will be what? 39.2 or 19.6? It will be 19.6 only. Why? Because when your boy reach here, the vertical displacement is only this much, not the total 39.6. Okay. So we'll use 19.6 only. N equal to 1 by 2. G value we will use how much? 10 and t square. So you can see here, this will again become, if we multiply it, it will become again 2 times, so it will become 39.2. You see, if you divide, you have 10 t square, right? So if you divide this 39.2 by 10, so it will be how much, right? So it will be around 3.92, right? If you divide it by, so if we take the g value 9.10, I think that will make little easier. If I use, instead of 10, if I use 9.8 g value, it will it will it will it will be 4, right? 4 times, right? The t value that you will get here, that will be what? Time it will take to reach to building B, that is 2 seconds. I hope it is clear. So now we have this time when your boy will reach at this point, right? So but we need the what? We need the minimum velocity. Okay, so we know this horizontal distance, right? So we apply the equation of motion in the horizontal direction, second equation of motion, that is x equal to uxt plus half axt square, and acceleration in the x direction is 0. This term will become 0, and so your x equal to uxt is remaining behind. So x is how much? Total horizontal range, right? Displacement, horizontal displacement, that is 20 meter. We have to find the ux and t that we have already figured it out, that is 2 seconds. So use 2. So ux will be 10 meter per second. So The boy have to jump with the horizontal velocity of 10 meters per second to reach at this point safely. So option A is correct, right? So now let me take our next question, question number 17. So this question is saying we have four bodies PQRS and pro- all these are projected with equal speed having angles of projection 15 degree, 30 degree, 45 degree and 60 degree with the horizontal. So we have to find with the body having the shortest range. So which body will have the shortest range? So this question is very easy. We just have to use the formula for range, and the formula for range is u square sine 2 theta by g, right? So before starting, one thing I hope you all know that horizontal range at complementary angles are equal, because when we put, what are the complementary angles? Theta and 90 minus theta, right? So if I put 90 minus theta in place of theta, so the formula will not change, right? So range on complementary angles will remain same. So can we see any complementary angles in the given questions? Yeah, 30 degree, 30 degree and 60 degree, right? Because I can write 60 degree like this, 90 minus 30. So 30 and 60 degree are complementary angles. So range on 30 degree and 60 degree will be same. So, but we are asked the shortest range. Okay. So first of all, let me find for 15 degree u square by g, that will remain constant in each in each case, and only the thing that will change is sine 2 theta. So sine for 15 degree 2 theta will become 30 degree, and sine 30 is what? Sine 30 is 1 by 2. So first is u square by g, right? Now let me take for 30 degree. For 30 degree u square by g, the formula will be 2 theta, right? So it will be what? It will be 60 degree. So sine 60 degree. So sine 60 will be what? Root 3 by 2. So it will be root 3 by 2 u square by g, right? And we know for R30 and R60 are same as they are complementary angles, right? Now let me see for R45 degree. For R45 degree, u square by g sine 2 theta. 2 theta means it will be sine 90 degree, right? Because theta is equal to 45 degree, so 2 theta will be what? 90 degree. So sine 90 we know what is. Value of sine 90 is 1. So answer will be u square by g. So now you see R15 is half of u square by g. R45 is u square by g, and R30 and R60 is what? Root 3 by 2. So what is the shortest range? You see R15, right? So R15 will be the shortest range. For 15 degree angle, the range will be the shortest, and how much it is? 1 by 2 of u square by g. Got it? So now let me move to the next problem. Problem number 18. Problem number 18. A particle is fired with a velocity u, making theta angle with a horizontal. What is the magnitude of the change in velocity when it returns to the ground? Right. So this question is also easy. So let's suppose we are throwing our particle from this point, right? After some time it reaches here. When it is thrown, let's suppose this is its initial velocity. So initially, what will be the component of this initial velocity in the x direction and y direction. So in x direction it will be u cos theta, right? Ux component will be u cos theta, and in y direction the component of the initial velocity uy, that will be u sin theta. Now you see, till the time your particle reaches the highest point, it's at highest point your vy becomes 0, right? And only the velocity is in u direction, sorry, x direction, right? Before that, before reaching the highest point, your vertical velocity is always in upward direction, right? But after reaching the maximum point, your vertical point, at this point it becomes 0, and after that your vertical velocity becomes downward, right? So ux will be in this direction, and sorry, vx, and vy will be in downward direction, right? So when your particle reaches the ground, right, its vertical velocity will be in the negative y direction and horizontal velocity will be in the x direction. Okay, so the only direction of y velocity, right, is changing. So initially, so if we take what will be the vx value after, so it will be equal to ux only, right? It will be u cos theta, right? And what will be this velocity? This velocity will be what? U sin theta, right? So what will be the, let me see, what is our initial velocity? Initial velocity, right? That is u. So initial velocity u will be what? Ux I cap plus uy j cap. So you just put the value of ux and uy, ux cos theta I cap, and uy will be plus u sin theta j cap, right? Now let me take the final velocity. Final velocity is vx I cap plus vy j cap, right? So vx is u cos theta, right? And vy is what? Minus u sin theta, because the direction has been changed now here, right? So that is your final velocity. Now we are asked the magnitude of the change in velocity. First of all, let me find the change in velocity, right? All these are vectors, right? So delta v will be what? Vf minus vi, right? That is your v minus u. So vf is what? Vf is your u cos theta I cap minus u sin theta j cap minus vi. Vi is your u. So u value is u cos theta I cap minus this value, no? U sin theta j cap, right? So you can see u cos theta will cancel out with u cos theta, and your delta v will be what? Minus u sin theta and minus u sin theta j cap. So it will be minus 2u sin theta j cap. So this is your change in velocity, but we are asked the magnitude, right? So magnitude will be what? Square 2u sin theta, right? So it will be 2u sin theta. So change in velocity will be what? 2u sin theta. So option 3 is correct. Got it? Now let me move to the next problem. Question number 19. Sorry, it's question number 14. Yeah, this is question number 19. So question number 19 is saying the speed of a projectile at its maximum height is half of the initial velocity. So what will be the angle of projection, right? So let me see, let me suppose initial velocity, initial, right, initial velocity is u, right? And we know at maximum height, the speed is becoming half, right? So, but first of all, we have to find what is the velocity at maximum height point, right? So we know at maximum height point, our vertical velocity is zero, right? Because after that, our particle starts returning downward, right? So Vy is zero. Only the velocity at highest point is present, that is Vx. And we know the Vx will be equal to Ux. X horizontal velocity remains constant during the projectile motion. So it will be U cos theta, right? So your total velocity at maximum point will be what? It will be only equal to V equal to Vx because Vy is zero. So total velocity at maximum point will be equal to only Vx, and that is U cos theta, right? So now the question is saying that at its maximum point, maximum height, its the speed becomes half of its initial velocity. So initial velocity was what? U. And it's saying at this maximum point, your this V becomes half. So V will be equal to U by 2, right? According to the question. Okay. Because it's saying that at the maximum point, your velocity becomes half of initial velocity, and initial velocity is U. So half of it will be U by 2. So your V will become half. So now you put the V value in the equation 1 and you will get U by 2 equal to U cos theta, right? So U will be cancelled out with U and you will left with cos theta, right? Now you see, so it will be theta equal to how much? 60 degree, right? Because cos 60 equal to 1 by 2. So your angle of projection will be how much? 60 degree. Let me move the question number 20. So question number 20 is saying a missile is fired for maximum range with an initial velocity of 20 meter per second, right? So G is also given 10. We have to find the range of the missile. So it's easy question, I guess. Right. It is fired for maximum range. Right. For maximum range. And maximum range is at which projectile angle? It is 45 degree, right? And range is what? U square sine 2 theta by G, right? So for maximum value, the sine 2 theta should be 1, right? As angle is 45 degree. So now your maximum range, right, will be U square by G only. So we have the value of U and G. So put, so 20 square by 10. 400 divided by 10. So it will be, your maximum range will be how much? 40 meter only. This was very easy question. Let me move to the next problem. Question number 21, right? So yeah, question number 21 is saying a projectile is fired at an angle of 45 degree with the horizontal. Right. The elevation angle of projectile at its highest point is seen from the point of projection. Right. We have to find the elevation angle. Okay. Let me see what is this elevation angle and all. Right. So first of all, let me draw the diagram. So your particle is with some velocity, and let's suppose it's following this kind of trajectory, right? So this is, let's suppose, initial velocity, and this angle is 45 degrees given to you, right? So when your projectile is fired at angle 45 degree with the horizontal, we have to find the angle of elevation angle of the projectile at its highest point. So when your particle reaches to the highest point, right? Let's suppose this is your highest point. We have to find the elevation angle. So elevation angle will be what? So it is asked from the point of projection. So elevation angle is something, if you are looking for your projectile, right? So what angle it made with horizontal? Okay. So this angle we have to tell. The 45-degree angle is not for elevation angle. Okay. This 45-degree angle is just projectile angle, right? This 45-degree angle was projectile. But we have to find this elevation angle. Okay. What is the angle will be made by with the horizontal if we see the our projectile at its highest point? Okay. Got it? So how can we find out? So angle is fired at 45 degrees. So this range will be maximum or not, because projectile was fired at maximum point, sorry, 45-degree angle, right? So it will be R max, and R max is what? U square by G. In the last question we see it, right? I hope it is clear, right? So this value will be how much? Let's suppose this is X, right? So X will be R by 2 or not, right? If this total is R, so this will be the R by 2, right? And what will be the height? This height, right? What will be this height if your projectile is fired at 45 degree? You see, at 45 degree, right? At 45 degree, we know the formula for u square sin square theta by 2g, right? So when 45 degree, it will be what? U square by 2g 1 by root 2 square, right? So it will be h will be u square by 2g and 1 by 2, so it will be 1 by 4 of u square by g, right? And this is what? This is nothing but your R max, right? So your h can be written as R by 4, right? So if I take the tan alpha here, right, in this particular triangle, right? In this particular triangle, if I give it a name O A B, right? So if I take the triangle O A B, right? And I take the tan alpha, right? Tan alpha is equal to what? Perpendicular by base. The perpendicular is AB, that is equal to H, and base is what? This OB, that is equal to X. So tan alpha will be equal to H by X, right? So H is how much? H is your R by 4, and X is what? R by 2. Right, so R will be cancelled out with R, and this 2 will cancel 4 by 2 times. So tan alpha will be what? 1 by 2. So your alpha will be nothing but tan inverse 1 by 2. Okay. So you see your elevation angle when you see the projectile from the origin, okay, then it will be tan inverse 1 by 2. Tan inverse of 1 by 2. So if your particle changes position and then we see the this alpha elevation angle, it will change, right? If it comes towards this or towards this, the elevation angle will change. Okay. So let me proceed to the next question. Question number 22. Right. So 22 number question is easy, I guess. The horizontal range, the horizontal range and the maximum height of a projectile are equal. So we have to find the angle of projection. So horizontal range and maximum height. Okay. So horizontal range is what? R equal to u square sine 2 theta by g, right? And what is our maximum height, right? Maximum height is u square sine square theta by 2g. So it's saying, according to the question, it's saying this h is equal to r, right? So just put the values of h and r equal to each other. So from equation 1 and 2, we can write u square sine square theta by 2g is equal to u square sine 2 theta by g, right? So u square will be cancelled out with u, this g will be cancelled out with this g. So we're left with sine square theta by 2 and this side sine 2 theta. What is the formula for sine 2 theta? It is 2 sine theta cos theta, right? So just put the values 2 sine theta cos theta. So this one sine will be cancelled out with this one sine, and this sine theta and cos theta. So this 2 will multiply with this 2, right? And this sine theta will be divided by cos theta and it will be 4, right? So sine theta divided by cos theta is what? Tan theta, and that is equal to 4. So your angle of projection will be tan inverse of 1 by 4, right? Sorry, not 1 by 4, it will be only 4, right? Yeah, we're just making this mistake. But this will be only tan inverse 4. Okay, how can it be 1 by 4? So not this one, this option 4 is correct, right? So your answer 4 is correct. Angle of projection will be tan inverse 4. Let me see the next problem. Problem number 23, right? So a projectile is fired with an initial velocity u making theta angle with a horizontal. If its range is 4 times the maximum height attained by it, is just extended form of this question, right? If its range is 4 times the maximum height attained by it, then we have to find the angle of projection, right? The same formula, this there we have the h equal to r, right? Here we have r equal to 4h given the question, right? R equal to 4h, right? This is given in the question. Its range is 4 times of maximum height, right? So r equal to 4 times of h max. So similarly, we put all these values here, right? The same things, all these will cancel out with each other, right? Let me do it again. U square sine 2 theta by g, right? U square sine square theta by 2g, right? This u square will be cancelled out, this u square, g will be cancelled out, this g square, right? So what we were left with? We were left with 2 sine theta cos theta equal to sine square theta by 2. This square will cancel out this, right? So we have this 2 will multiply with this 2. So we forgot this 4, right? We forgot this 4 here. So we have to use this 4 also here. H max, right? So it 4 will also be here. So you see what will be the angle in this situation, right? So it will be this 2 will cancel this 4 by 2 times, and this 2 will also cancel out this 2, and we will only have sine theta by cos theta equal to 1, right? Which means tan theta equal to 1, which means theta equal to 45 degree, right? I hope you understood this. Let me explain it again. Here r was equal to 4h, right? So this formula u square sine square theta by 2g, 4. This 4 is here. H formula is u square sine square theta by 2g. So this g will cancel out this g. U square will be cancelled out this u square. And this 2 right here. This 2 and this 4, if we cancel out, it will cancel it 2 times, right? Then we put the formula for sine 2 theta, that is 2 sine theta cos theta. So now this 2 will be cancelled out with this 2. And here we have sine square theta, right? So one sine will be cancelled out with the another sine, and we'll have only sine theta and cos theta in left hand and right hand side. It's like this. Cos theta equal to sine theta, right? So both are equal to each other at 45 degree only. Okay. Another way is tan theta equal to 1, and then it is theta equal to 45 degree. I hope it is clear. So option A is correct. Right. So let me move to the question number 24. So question number 24 is saying the velocity of a projectile at the initial point is 2ik plus 3jk, right? And its velocity at point B when it returns to the same horizontal level is what? So let me just draw. Let's suppose this is its some initial velocity u, right? So it's saying your velocity of particle projectile at initial point. Let's suppose the initial point is somewhere here, right? That is 2ik and 3jk, right? If you take it as a, okay. So at this point, the velocity is said 2ik plus 3jk, right? Which means x in x direction, the velocity is in the x direction velocity is 2ik, and y direction it is 3jk, right? So we are asked when your particle returns to the same horizontal level. So when it will return to the same horizontal level, so let me so it will be around here, right? When your particle after reaching the maximum height, when it comes downward, so there will be a point, the level horizontal level will be the same, right? So at this point, I already told you in the previous question that velocity vector in the y direction will be downward up while returning back to the ground. So here your velocity vector in y direction will be opposite to the initial one. So this time it will be 3j cap, and velocity vector in x direction will be the same of previous one. Okay. If we take point, so this was point. If we take the point A here and point B here, then also we can say the horizontal level is same, right? So then also we can initial velocity if we say then also it will be same, right? 3 I cap and 2 j cap, right? So here also it will be like this. It will be 2 I cap and 3 j cap, you see, right? So while returning back, your velocity in y direction will be downward, not upward direction. Okay. So only the velocity in the y direction is changing. The velocity in the x direction is remaining same. So your initial at point A, your velocity vector was what? 2 I cap, right? Plus 3 j cap. And what will be your velocity vector at final point? Point B, that will be 2 I cap will remain same, right? Only your velocity vector in the y direction is now downward. Earlier it was upward, now it is downward. So direction has been reversed. So its direction now will become minus y direction, that is minus j cap. So this velocity at B point will be 2 I cap minus 3 j cap. I hope you understood this question. So let me move to the next and final question. Okay, question number 25. Right. So question number 25 is saying a projectile is fired from the surface of the earth with a velocity of 5 meter per second and angle theta with the horizontal, right? So let me just draw the diagram. Surface of the earth, right? So the initial velocity is 5 meter per second, right? And the angle theta, right? The angle is theta. With the horizontal, another particle is fired from the another planet. Okay, so this was, let's suppose, Earth, right? So let me take another planet. Okay, then we are again projectile with fired and projectile with a velocity of 3 meter per second. So on another planet, the velocity is 3 meter per second, right? At the same angle is same theta, right? Follows a trajectory identical with the trajectory of the projectile fired from that. So the question is saying this trajectory of projectile and this trajectory of projectile on this planet are same. Okay, trajectory, right? Question is saying trajectory of projectiles on Earth and planet is same, right? This is your question is saying. And also the angle of projection theta is also same, right? So we have to find the value of acceleration due to the gravity on the planet. We have to find the gravitational acceleration at this planet. Okay, we have to find Gp. So Ge is given to us, that is 9.8, right, meter per second square, and we have to find Gp, right? And what else is given to us? U. Speed on the earth is given of projectile is 5 meter per second, and on planet it is given 3 meter per second, right? So first of all, we have all the information gathered from the question. So the first information is the trajectory is same, right? So we know the equation of trajectory in case of projectile, right? So what is that? That is y equal to x tan theta, right? That is y equal to x tan theta minus g x square to u square cos theta, right? That is your equation of trajectory, right? Now we are said this on the earth and planet this trajectory is same, right? Let me take for this earth. The trajectory is same, which means y and coordinates of particle trajectory at any point will remain same. So what is the thing that is changing, right? So once its speed is different on earth and planet, and the gravitational acceleration will also be the different. Theta is same, that is given in the question itself, right? And trajectory is also same, which means x and y coordinates will also remain same, right? So this is for your earth. If you write the same trajectory equation for planet, right? So it will be y equal to x tan theta minus gp x square to u square p cos theta. That will be equation 2 or not? Yes. Now you see, if we compare or equate both the equation, if we equate equation 1 and 2, this will be cancelled out, right? This part, all things will be cancelled out, right? So let me do it just for your. So if we subtract equation 1 minus 2, right? So it will be all x tan theta minus ge x square 2u square cos theta, right? Minus x tan theta minus minus will be plus, right? Gp x square 2u square p cos theta, right? So you see this x tan theta and x tan theta will cancel out, y will be cancel out, right? So we'll left with only 0 equal to, here we have minus gex square 2u square e cos theta plus gpx square 2u square p cos theta, right? So you see here x square cos theta and 2, x square cos theta and 2, all these are common. So I will take this common and put it outside, right? So it will be x square by 2 cos theta, right? And I have minus GE upon u square plus I have GP upon u square p, right? So this value will go inside in towards the zero, and we'll have only this, right? So we have minus GE upon u square e, right? It is GP upon u square p, right? That is equal to 0. So it will be what? GE equal to u square e, GP equal to u square p, right? So we have all the values. We know that GE is given to you. G is 9.8. U is given UE. Velocity of your projectile at Earth is given 5. So 5 square will be 25. GP we have to find out. And UP is given to you 3. So it will be 3 square. That will be 9. Right. So we are given 9.8 or 10G value in the question. It is given 9.8. Okay. So it will be GP will be what? 9.8 multiplied with 9 and divided by 25. Right? So if you solve it further, right, it will be around your GP will comes around 3.5 meter per second square. Okay, got it? So option A is correct, right? So I hope you enjoyed all the problems and you understood all these problems very well. You can tell me for any kind of improvements and problems that you want to like see in the next video. Okay, you can tell me in the comment section also, but please uh, comment about the this particular video or about all the problems, you please mention in the comment. So thank you all. See you in the next video. Bye bye.